Hello and welcome to this video on scalar multiplication of a matrix. In this video, we're going to be covering how you can multiply matrices by a constant number, similar to how you can add and subtract whole matrices. So when we are multiplying by a constant number, these type of constant numbers are called scalar quantities. So a scalar quantity is different from what is known as a vector quantity. We're going to be talking about vectors later on in this chapter, but for now we're going to stick to what are called scalar quantities. Basically, scalars have what is called magnitude, and that you can see right here. Magnitude is just how much of a thing you have. The good examples of this would be time. How much time is there? 60 minutes, 4 hours, 9 days. Or temperature, you have 20 degrees or negative 80 degrees. And then distance is just how far you've gone. I've gone 100 miles, I've gone 12 feet. There's an amount. These don't have direction. And when we are multiplying a matrix by a scalar quantity, all you really have to do is take the amount that you are multiplying by and multiply that scalar amount by each number at every single part of your matrix. So for example, we have matrix A right here in front of us. We have 4 elements, row 1, column 1. Remember that this A with little 1s next to it, that just means that matrix A, column 1, row 1, which would be this element right here. Compare that to this one, row 2, column 2 would be the bottom right of this matrix. So if I was going to multiply by any number, it could be a fraction, it could be a decimal, it could be a whole number, it could be a negative number, whatever you want to multiply by. If you're multiplying that matrix by a scalar quantity, which is C, any number, you just multiply C by each element inside of that matrix. Pretty straightforward. And this will also apply with dividing. Like you could divide every element in a matrix by a number. So you could think of it as like I could multiply by 0.5 as my scalar quantity, or I could divide by 0.5. Those mean different things. Or you could do the same thing in different ways. Like I could multiply by 2, or I could divide by 0.5, or I could multiply by 0.5 or divide by 2. It kind of goes in both directions. But generally, that's all you really need to worry about. So generally speaking, if you're talking about multiplying by a scalar, just like how adding and subtracting with matrices works similar to when you're adding and subtracting regular numbers, that is the case here as well. So the distributive property is something that still holds. So if we had an example with a matrix, you have one matrix being added together and then multiply that result, that sum, by a number, it would be the same thing as multiplying each matrix by itself. And then vice versa, you could have, you add the two matrices together first and then multiply at the end here, and that would be the same thing as the two scalar quantities being multiplied by the one matrix. Remember that a matrix is usually a capital letter, and the scalar quantity is usually the lowercase letter instead. And those are the main notes you need to know before trying some scalar multiplying matrix problems. Now let's start the 3 examples that we are going to cover on scalar multiplication of matrices. So in number 1, we have matrix A, and we have 4 elements in matrix A. Remember, this is a 2 by 2, 2 rows, 2 columns. And we have a scalar quantity of 3. So we basically are doing 3 times matrix A. So if I would do that here, I would basically be doing 3 times the full matrix. I could write it like that. It's kind of an in-between step. And then second step would be 3 times each element on the inside. And I get that as a result. And then finally, all I would need to do is actually multiply everything out. So I would get 24 in our first column, first row, for instance, and then I could fill in the 3, 15, and 12 that the answers would end up being. It's pretty straightforward stuff. We have a matrix we start with. If your scalar is 3, basically tripling every number inside of the matrix to get to your answer. Moving on to number 2, we have a matrix B, but now we're multiplying it by a -2. So we have -2B would be basically -2 times the whole matrix, 4, 1, 3, and 2. And then you could write that next to it as a little -2 times each one of these elements. And you would get that as your next step. So you can see that -2 is being multiplied to each thing on our paper in front of us. And then our answer would be just multiplying out these 4 multiplication problems. And the 4 numbers that you would get would be -8, -2, -6, and -4. And that would be our final answer for that problem in particular. Now, matrix problem, scalar multiplication problem number 3 here, we need to do a little bit more work. So we have a new problem where we have 3 is our scalar quantity times A, and we got to add that to 2 times a scalar quantity of B. And so we need to use what we learned about yesterday in our last video to add them together as our last step. But first, we need to do 3 times A and 2 times B. So let's do that first. So we have 3A, which now we can kind of skip ahead a little bit because we're more used to it now. I'm going to triple every item in this whole matrix. Some of them are zeros that are not going to change. So we'll kind of see that happening as we go. So our first row would be 3, -6, and 0, multiplied by 3 in all of them. And then we have 0, -3, and 6. And then we have 3 times 4 on the bottom is 12, 9, and -18. We now need to double everything in B. So we need to make 2 as our scalar, multiply by matrix B. So I'm going to double all 9 elements of that matrix right there. So I would have -2, 4, and 2 in my first row. I would have 0, -6, and 4 in our first row. And I would have 0, 2, and -8 in my last row. All that's left to me now is I needed to add all of this together. So if you recall from yesterday, we had a problem where we are adding matrices. So you just need to match up like first row, first column to first row, first column. So for instance, I would do 3 plus -2. 3 plus -2 is 1. And then I can just go across the row. -6 plus 4 is -2. 0 plus 2 is 2. And then I can just fill in the rest as I go. And we get to an answer at the end for this whole thing as a matrix here that is 3A plus 2 times B. And that completes this matrix addition scalar multiplication problem that is kind of combining what we've been working on lately in class. And that concludes this video on scalar multiplication of matrices. Thank you for watching.